This is a continuation video of graphing linear inequalities. So what we're going to do is we're going to solve all of our inequalities that are given. We're going to solve them for y. And then we're going to make a sketch that looks similar to this and plot our values. And it's going to be shaded either less than, as in this example, or be shaded greater than, as shown in this example. So remember, if you have a less than or equal to or a greater than or equal to symbol, you are going to have a solid line on your inequality graph. And if you have a less than or a greater than symbol, that's going to create your dotted line. Now remember, we talked about this in class, that everything in this shaded region just shows that an ordered pair that's larger or greater than or equal to this line makes the inequality a true statement. Same for here. Any ordered pair in the shaded region that's smaller than or less than this dotted line, those ordered pairs make the inequality statement true. So let's take part A here. We've got 6x plus 3y is greater than 9. So I'm going to subtract 6x. I'm just going to basically put every inequality into a slope-intercept form. So 3y is greater than negative 6x plus 9. Divide by 3. And I get y is greater than negative 2x plus 3. So I'm going to sketch. And I want to sketch my intercept, so 0, 3. And then I want to plot my slope, which we've done this before. That would be decreasing 2 and increasing 1, or increasing 2 and decreasing 1. Now the question is this going to be a solid line or a dotted line? And it comes from right here. So we know that's going to be dotted. So a dotted line here, and I want everything greater than. So all the values, all the ordered pairs that are greater than this dotted line, all the ordered pairs in that shaded region make this inequality statement true. So if we go to a new one, so 2x minus y is greater than or equal to negative 1. So 2x minus y is greater than or equal to negative 1. So that we're looking at part B. Just by looking at the inequality and see that you have the greater than or equal to, so you know it's going to be a solid line when you graph the inequality. So we're going to solve it for y, and I'm going to subtract 2x from both sides. So I get negative y is greater than or equal to negative 2x minus 1. And something we have to be careful of is that since I'm dividing by a negative 1, coefficient is dividing by a negative, that's going to cause me to switch the inequality symbol from greater than or equal to a less than or equal to. Negative divided by negative would be positive. So we'll do our sketch. And we're going to plot our intercept at 1. And then we're going to plot our slope of 2 to 1. Increase 2, increase 1, decrease 2, decrease 1, and it is going to be a solid line. Now I want everything less than or equal to. So all the values below this line or less than this line would work, okay? So next one would be 4x plus 2y is less than or equal to 5. So 4x plus 2y is less than or equal to 5. That is part C. We see the less than or equal to, so we know we're going to have a solid line. So we're going to solve for y, put it in the slope intercept form. So 2y is less than or equal to negative 4x plus 5. And I'm going to divide by 2. So y is less than or equal to negative 2x plus 5 halves, or 2.5. And so I'm going to plot my point at 2.5. So 1, 2, 3. So there's 2.5. And so I want to decrease 2. So decrease 1, 2, to the right 1. So I'm at 2.5. I need to decrease 2, increase 1, or increase 2 and decrease 1. So it's going to be a solid line. And I want everything less than. So I want everything in this region less than the line. So another equation, so negative 4x plus 6y is less than negative 12. That's the next one we're going to look at. Negative 4x plus 6y is less than or equal to negative 12. So I'm going to change that to less than, not less than or equal to. And we're going, since we know it's less than, then that's going to equal that dotted line. So we're going to go ahead and solve for y. So I'm going to add the 4x to both sides. So I get 6y is less than 4x minus 12. I'm going to divide by 6. And so I'm going to get y is less than 4/6, or 2/3 x minus 2. So this is the inequality that I want to sketch. And I want to plot my intercept at negative 0, negative 2. And then I want to plot apply my slope to my intercept. So increase 2, increase 3. Or decrease 2 and decrease 3. And it's going to be a dotted line. And now I want everything smaller than this line, or less than this line. So everything in this region, an ordered pair in that region right there should make this inequality a true statement. So let's say we just check that. Okay, so let's say 3, negative 5. So if we substitute a negative 5 in for y, a 3 in for x, so this would be 6/3, or 2. Negative 5 is less than 0, and that's a true statement. So let's look at E. X plus 3y is greater than or equal to 0. So x plus 3y is greater than or equal to 0. So I'm going to subtract x, and I get 3y is greater than or equal to negative 1x. Divide by 3. and I get y is greater than or equal to negative 1/3 x. Since there's not an intercept written here, we know that it's going to go through the origin. With a slope of negative 1/3. So I'm going to start at 0, and I'm going to decrease 1, and I'm going to increase 3, or I'm going to increase 1 and decrease 3. And it is a solid line since greater than or equal to. Go through the ordered pairs there, and I want everything larger, everything greater than. So everything in this region up here. Every ordered pair in that shaded region will make this inequality a true statement. So those are some examples, more examples of graphing linear inequalities. And just remember that when we're graphing these, we want to solve for y. So put the inequality in y-intercept form. We want to be careful when we have to divide, for instance, by a negative. That's going to switch the inequality sign from, like, for instance, from a greater than to a less than. And then we want to sketch. So when we sketch, we want to plot the y-intercept and then apply the slope.